So dear students, today we are going to read how to convert alkene to all other compounds, right? Alkene, that is your alkene to all other compounds, okay? First of all, we are going to prepare alkane. How will you prepare alkene from alkene? So suppose you have CH2 double bond CH2, then you have to react this with hydrogen in the presence of PT, palladium and platinum. You have to reduce this one, right? This will give you CH3, right? Second is to alkyne. How to prepare alkyne from the alkene? Okay, so the first step is react this alkene with halogen in the presence of light to give CH2X. This is the dihaloalkene, right? Now you have to do dehydrohalogenation of this one to produce alkyne, right? Now to alkyl halide. Okay, so first reaction, suppose when you are doing a reaction of alkene to produce alkyl halide, suppose this is, you are reacting this one with this will produce CH3 CH2X. This is your symmetrical, right? This is your symmetrical hydrocarbon, right? This is your symmetrical alkene, right? With symmetrical alkene, you don't need to think what is going to happen. You simply add one hydrogen to one side and halogen to the other side, right, of the double bond. But if there is unsymmetrical alkene, suppose there is this one, this is your unsymmetrical alkene. How? Look here. This side after double bond, only one carbon is over here, but this side there is two carbon. This is unsymmetrical alkene, and when you react this with HX, so what will happen over here is, look at, this is electron donating group, right? This one is electron donating group, right? So what happens, this gains positive charge, partially positive charge, and this gains partially negative charge, right? And this one is your positive charge and this one is your negative charge. So look here, this positive charge is going to attack over here and this negative charge is going to attack over here, and this will be forming CH3 CHX, and this is your CH3, right? Suppose if you are reacting this with HBr, okay, hydrogen bromide, in the presence of H2O2. This is peroxide, right? So now there is peroxide effect. Now peroxide effect is seen. Look here, this peroxide effect is only seen in the case of HBr, okay? This will give anti-Markovnikov's product, that is not following this rule. So this will be giving CH3 CH2 CH2 Br, right? So this is what happening. So now, okay, in next slide we will be preparing how to prepare the alcohol from the alkene, right? So let me remove all this stuff from here so that we can read further. Okay, look here. So preparation to alcohol, right? We are preparing alcohol. Now suppose this is CH3 CH double bond CH2 and you are preparing alcohol. So let us react this with water. Water gives H plus and OH minus ion, right? So this one is partially positive and this one is partially negative, that we have discussed already in the previous video. This OH minus is going to attack over here and H plus is going to attack over here, and this, the product will be CH3 CHOH. Okay. Hydroboration reaction. What is hydroboration reaction? Look, this is your, suppose this is CH3 CH double bond CH2 and you are reacting this with, first step you are reacting this with PS3, and secondly you are reacting with H2O2 in the presence of NaOH, right? So this will give you CH3 CH2 CH2OH. This is your primary alcohol, right? So next, conversion of this to the aldehyde and ketone, to aldehyde and ketone, right? So how will you react? Suppose this is your CH3 CH double bond CH2 and you are reacting first step with ozone, right? Then this will give you like this, okay? This one is your C. Okay, so look here, you have to break this bond, right? One part, look at C, and there is two hydrogen, so one hydrogen over here, one hydrogen over here. Next part is, then there is 2C, right? So this is CH3, this one, and there is one H, so this H is over here. Now we'll have to do hydrolysis in the presence of zinc. Now this will break like this. Can you see HCHO, right? This is your formaldehyde, plus, and this is your CH3CHO. So this is your CH3CHO. This is your acetaldehyde. Okay. Okay. So now, we'll be preparing ketone from here. Ketone, right? Now let's see. Suppose you have CH3, CH double bond, right? C, CH3, CH3, like this compound you have, okay? And now you would like to react this with ozone, O3. Look here, this bond is going to lysis of this bond will occur, and this will give you like this. Now look here, one C is over here, this is attaching itself with 2CH3. Look this one, this C is attaching to this CH3 and this CH3, and this side it is attaching one to H and another to CH3. This one, when we further hydrolyze it in the presence of Zn, this will be breaking like this, right? So look here, this is CH3CHO, CH3CHO plus this one is CH3 C double bond O CH3. So this is CH3 C double bond O CH3, right? So this is your propanone, right? Which is your ketone, right? This one is your ketone. Look here, this one is your ketone. Okay. So now we'll be preparing carboxylic acid from the ethene. Carboxylic acid to what? Carboxylic acid. Okay. Look here, suppose this is your CH3, CH double bond, CH2, and you are reacting this with alkaline KMNO4. Okay. So this bond will break like from here. This is hot, okay, hot alkaline KMNO4, and this will produce from here. This is one acid and this is another. Okay, so this will produce CH3 COOH plus HCOOH. Okay. Second, suppose this is CH3, this is C, this is CH3, this is double bond, this is CH2. Look here, the condition is same applied over here, but this time there is no hydrogen on this carbon. Look at, there was hydrogen on this carbon, but there is no hydrogen on this carbon. So bond will lies in such way that this will produce CH3 C double bond O CH3. This will give ketone, right? And this carbon has still one, two, and there is hydrogen attached to this carbon, so this will give you HCOOH. Okay, are you understanding? This carbon must have hydrogen with it to give acid. Are you getting it? Okay, so now we'll be trying to prepare nitro compounds from the alkene. Okay, from the alkene we are trying to prepare nitro compounds. Okay, so first of all, suppose you have this, suppose CH3 CH double bond CH2, and we reduce this one in the presence of hydrogen by the use of PTPT. This will give you CH3 CH2 CH3, right? We react this with fuming, that is a vapor phase, SNO3. So this will give you CH3 CH2 CH2 NO2, right? CH2. Okay, once more, let's see here. So what did we do? CH was CH3 CH double bond CH2. We reacted this with SNO3, that was vapor phase SNO3, and this was giving you CH3 CH. Okay, so okay, we missed it. First of all, we have to convert this into alkane. Okay, alkane, and then we do this one. So this will produce NO2. Now this is the nitroalkane. From nitroalkane, if we reduce this one in the presence of SnHCl, this will produce CH3 CH2 CH2 NH2. This is your amine, right? From this alkane, that is your propane, CH3 CH2 CH3, we can react this with X2 to produce CH3 CH2, and this is your CH2X, and we react this with KCN, right, to produce CH3 CH2 CH2CN, right? We can react this with AgCN, alcoholic AgCN, to produce CH3 CH2 CH2 and this is your isocyanate. This is how we prepare the nitro compounds from the alkene. Okay, are we done? Yes. There is one more video, one more slide to understand how to convert alkene to ether. Alkene to ether. Okay, alkene to ether. Okay, let us convert alkene to ether. Suppose we have CH3, CH double bond, CH2, and we are reacting HBr in the presence of H2O2. This is your anti-Markovnikov's effect. This will follow anti-Markovnikov's rule. So this will give you CH3, CH2, CH2, Br, right? And when we react this with Ag2O, so now what will happen? Two molecules of this one will react with this Ag2O. How many molecules? Two molecules will of this one react to produce CH3, CH2, CH2O, CH2, CH2, CH3. This is your ether, right? And 2AgBr, right? So this reaction will give you ether. So next reaction is you can react this one with, that is your Hg CH3 COO whole 2. This is your when you react this one with this, and in secondly, this is the first step. In second step, you have to react this with uh, secondly you have to react this is the first, this is mercuric acetate, right? This one is called mercuric acetate, and then you have to react with alcohol in the first step. Okay, CH3OH in the presence of CH3OH, then there should be alcohol and mercuric acetate, right? Then secondly you have to do react with NaBH4. In the first step you have to use mercuric acetate and then one alcohol, and then in second step you have to use NaBH4 in order to produce this one, CH3 CH3. This is your CH3. Okay, this is your 1 2 3. So this is your 2 methoxy propane, right? Propane. This is your alkoxy. This is your alkoxy mercuration alkoxy mercuration demercuration reaction. This is your alkoxy mercuration demercuration reaction. Okay,